Hello everyone, my name is Sam and I'm going to show you how to configure site-to-site VPNs using crypto maps. This is the network topology I'm going to use for this demonstration purpose. I have two routers, R1 and R2. R1 is connected to host 1, R2 is connected to host 2, and this is the IP addressing scheme I'm going to use for this demonstration purpose. I already have the IP addresses assigned to the interfaces. Show IP interface brief. There you go. There you go. And I already have a RIP routing protocol running on both the routers. There you go. And host 1 is able to ping host 2. So I'll do a quick ping 11.1.1.2. There you go. So host 1 can ping host 2. And to set up the VPN between both the routers, the first thing you need to do is configure an ISKM policy on both the routers. So I'm going to hop onto router 1 and say crypto ISKM policy 100, encryption AES 128, authentication pre-share, hashing is going to be SHA, group 2 is the Diffie-Hellman group, and I'm going to say the lifetime is 86,400 seconds. And I need to apply the same configuration on R2 as well. So I'm going to say do show run, include the section crypto. Okay, I'm going to copy this from here, hop onto router 2, just paste it here. There you go. The next thing to do is to configure the identity that is going to be used for the VPN connection. So I'm going to say crypto ISKM identity address, and the same thing on router 2, crypto ISKM identity address. The next thing to do is to define a pre-shared key on both the routers. So I'm going to say crypto ISKM key 0. Cisco is going to be the key, and the address for this key will be 192.168.1.2. Say enter, and crypto ISKM key 0 Cisco address 192.168.1.1. Okay, the next thing to do is to create a transform set. So I'm going to say crypto IPsec transform set. I'm going to name it trans, and it is going to use the algorithm ESP AES 128, ESP SHA HMAC, and mode tunnel exit. The same thing on router R2, crypto IPsec transform set trans ESP AES 128 ESP SHA HMAC mode tunnel exit. The next thing to do is to create an access list that is going to define the interesting traffic that is going to trigger the VPN. So I'm going to create an access list, IP access list extended. I'm going to call it VPN, and I'm going to permit the traffic from the 10 network to the 11 network. So I'm going to say permit IP 10.1.1.0 0.0.0.255 to the destination 11.1.1.0 0.0.0.255. Exit. And we need to create an exact opposite access list on router R2. So I'm going to hop onto router R2 and say IP access list extended VPN. I'm going to say permit IP. I'm going to permit the traffic from the 11 network to the 10 network. So I'm going to say 11.1.1.0 0.0.0.255 to the destination 10.1.1.0 0.0.0.255. Exit. The next thing to do is to create a crypto map on both routers. So I'm going to say crypto map. I'm going to name it as crypto. The sequence number is going to be 100 IPsec ISKM, and I'm going to set the transform set over here as trans. I'm going to set the peer as 192.168.1.2. The PFS group will be group 2, and again I'm going to set the security association lifetime seconds 86,400, and match the access list, which is VPN. There you go. Exit. I'm going to hop on router 2 and do the same thing. Crypto map crypto and the sequence number is going to be 100 IPsec isocamp set transform set trans set peer 192.168.1.1 set PFS group 2 set security association lifetime seconds 86,400 and match the address VPN. That's it. Next, I need to go into the interface under which the crypto map is going to be applied. In this case, it is going to be the serial interface 0/0 on both the routers. So I'm going to router 1 and say interface serial 0/0 crypto map crypto. Exit out of it and go to R2 interface serial 0/0 crypto map. I'm going to say crypto. Exit, and to verify I need to say show crypto session. Okay, the session status is down. Let's do a ping from host 1 to host 2. I'm gonna say ping 11.1.1.2. Okay, and now I'm gonna check show crypto session. There you go. Show crypto session. There you go. Thanks for watching.